Okay, the final step for scenario one is going to be calculating the least cost alignment. So this is kind of what we've been working toward, creating the optimal least cost path between the source electrical substation to the destination electrical substation. Again, we could have just drawn a line, but then it wouldn't be as interesting because we're using all these input data based on community consensus. So it becomes a really good kind of decision-making tool. Um, and the tool we're going to use for this uh, in ArcGIS Pro is called Optimal Path as Line. So let me go to, and we'll use pretty much the same uh, inputs and output names that are in this dialog here. So let me go to ArcGIS Pro, go to geoprocessing, and I'm going to type in optimal path as line, spatial analyst tool. And this time, the input or the feature destination data layer is going to be the line destination. So we're essentially going from here to there, right? We can use the default ID here as the destination field ID. The input distance accumulation raster is going to be that scenario one suitability cost grid there. And that was the cost accumulation, the one we're looking at right here. And then the backlink is the um, flow direction raster that we need. And then our output is actually going to be a feature layer. Um, and I want this in that same data set. So wait a second, go to suitability. So it should be in here. I'm going to name it S1 optimal line, save. And then I don't want a path type for each zone. I just want best single path. Okay, and it's going to create a feature layer showing this path between here. So this is kind of where the magic finally happens. Run, and there we have it. This is the optimal path between the origin substation, electrical substation, with the solar array up here, and the destination, based on all of these assumptions that we've created throughout the scenario. Um, for your um, for your PowerPoint presentation, what I'd like to see is essentially this alignment um, overlaid on top of your cumulative cost grid, which would be the S1 suitability or S2 suitability. Um, and you can, make some changes to this to make it a little bit more visible. I'm going to make this a lighter color. Let me see here. Um, where are all my? Well, I guess I could do just this, and then I'm going to invert, not invert. Okay. And then I can also make this line a little bit wider to like 3 point. Okay. Okay. And now you can see it a little bit better. You can go to sharing. I'm just gonna like close this a little bit. Go to share, and then capture to clipboard. Go over to my instructions, or not actually the PowerPoint, and you can remove the one that was there and paste it with this new one. I'm not asking you to do a lot cartographically here because you did so much analytically in this exercise, but this would be the result. And you can, I'd like you to write up a little bit more here, like why you chose the input and the transform layers and the weights for these. The last step we need is to get the total distance of this optimal path in order to calculate the total cost, and that way we can compare the two scenarios just in terms of dollar values and distance. So let's go back to ArcGIS Pro for this final step. If you right-click your optimal line and go to Attribute Table, you'll see a shape length, and that shape length is in meters. So I'm going to just pull up a calculator here. And so I have 88,974. And if you divide that by 1609 number of meters in a mile, that's about 55 miles in my case. So, and then multiply 55 by 5 million, and that's $276 million dollars. So I go back to my PowerPoint here. I'm going to type in 55 and then 55 miles times that, and that's 276. So that's it. And for this scenario, I know that's a lot of steps, but it is an interesting exercise and it can be applied to a lot of different things. And now you know how to do a suitability analysis.